So, when you're approaching a problem with an incline, the first thing you do is you want to draw your free body diagram. Okay, so I always draw a hill, and I put my box on the hill. When you're doing a problem with an incline, you're changing your X and Y axis to match the hill. What does that mean? Well, now the X direction is going to be the same as the hill, and the Y direction is going to be perpendicular to the hill. Why is this? Well, you want to make it easier to do the math. You want to make it so that way you're only accelerating either in the X direction only, meaning in the plane of the hill, or in the Y direction only, which will not happen when you're talking about an object moving up or down the incline. So, after you draw your free body diagram, you're going to do the same thing you did before. Is there gravity? Yes. Okay. Gravity always goes straight down, no matter if the incline exists or not. Doesn't matter. Straight down. Now we look for the surface, the normal force. Remember, the normal force is perpendicular to the surface that the object is on. So since the object is on an incline, you have to match the 90 degrees to the incline itself. If you were to turn the paper back flat, you'd see that it's still straight up. Okay, now read the situation. A box is being pushed up a hill. So if I'm pushing up the hill, I have a force applied. In this problem, it tells friction. So friction always goes the opposite direction of motion. The motion of the object is going up the hill, so friction has to go down the hill. Whenever you're doing an incline problem, you want to break your FG into its component vectors. Since FG does not fit on the X or Y plane, like so, this would be the X plane, and this would be the Y plane, your FG does not fit on either of those. So you have to find its component vectors. FGY and FGX. Now that you have all the forces drawn on your free body diagram, you're going to do the same thing you would for a normal free body diagram problem and write your X and Y direction equations. The object is going at a constant speed. When we're going at a constant speed, we are in equilibrium. So that means both of them are equal to 0. Now you just got to write what forces do I have drawn on my free body diagram in the X direction. Okay, FA and F are the easy ones. Just make sure you don't forget your FGX. So up the hill is positive, down the hill is negative. In the Y direction, you only have 2 forces. Remember, FG is not in the X or Y plane, so do not include it in your equations. From this point, if I were to give you values, you could rearrange and solve algebraically.